Okay, welcome back. We're looking at question 1 from the 2020 State Exam Commission sample paper that was brought out before the new junior cert cycle, the junior cycle math syllabus came in, or specification came in. Okay, so let's jump straight in. We're doing question 1. We know there's 14 questions on the paper, and the suggestion is we stick to 5 minutes. Okay, so let's read the question carefully for understanding. Write the numbers 3, 9 and 25 into the 3 empty boxes below to make the mathematical statement true. Okay, use each number only once. Great. Okay, so just looking at 24 over 25, we can see that it's just less than 1. So clearly, when we're wondering what will go with over 5, it could not be 9 and it could not be 25. So we're going to dial in, if you like, a 3 here. Okay, so we have 3 over 5. Now the next thing is that whatever we add to this is going to end up with an over 25, so we couldn't go over 3 or over 9 next. So it has to be 25 at the bottom, and that just leaves 9. Okay, again, if we were to take these two leftover numbers, we couldn't put them the other way around as well, because we'd have gone over 1. So really just this is the only options we have. So just to make sure, we could use our calculator to check, or we could use mental maths or pen and paper maths. Like if I was to multiply this by 5 over 5, this would turn into 15 over 25, and 15 and 9 is indeed 24. Okay, well, I'll just do that on the calculator as well. 3 fraction bar 5 escape plus 9 fraction bar 25. Okay, and that is indeed equal to 24 over 25. So that's that question finished. And the only thing I would say there is use logic and inequality principles. Okay, we've used inequalities to say, well, this here, when we're has to be less than 24 over 25, or our guideline was less than 1. Okay, on we go. Again, write the numbers 3, 5, 9 and 25 into the empty boxes below, so that the difference is highlighted in bold, but we'll underline it as well. Difference means subtraction between the two fractions is as large as possible. And then again, use each number only once. So if the difference is going to be large as possible, we're going to have this one being as large as possible and this one being as small as possible. So how can we get the largest possible number we can here? First of all, they're both going to be positive, and in that sense, because they're both going to be positive, I think the biggest gain will be getting as large a fraction as possible. So again, logic kicks in. It says, how do I make a fraction large? You make the numerator as large as possible, which would be 25, and you make the denominator as small as possible, which would be 3. Okay, now that leaves, so assuming we're on the right track here, that leaves 5 and 9, and we want this to be small, as small as possible. So do we want the 9 over 5, or do we want the 5 over 9? Obviously we want the small number over the big number. Okay, so we went with the biggest over the smallest, and then we went with the smaller over the bigger of what was left over. Okay, and we can check the value of the answer, which will be 70 over 9, and that will be the biggest, but there's nothing much else we can do. Only we can say we've used logic and that should be the answer. Now why am I writing things like this is, let's say I'm wrong. suppose the marking scheme, there is no marking scheme for this, by the way, so it's a bit of a, I'll be making it up as I go along. But as a general guideline, you could say the scores here would be 0, 2, 3, 4, and 5 if it's a full E scale. And you know, how would you possibly score 2? Well, any number in the right place would probably get you 2. Any wording that says your technique that's valid would get you 2, or maybe even 3. Like, let's say you did the wording and the correct number, you might get 3. 4 would be for a tiny slip. Who knows how it would go on this one. Okay, we're going to drive on. So next we have a positive whole number has exactly 4 factors. One of the factors is 9. Work out the number. Okay, now if a factor is 9, its prime factorization. Its prime factorization, of course, is 3 3s. So let's say we just start exploring here and say, well, we know the number has to contain this, and it has exactly 4 factors. Now if we just leave it at 9, we're going to end up with 1, 3, and 9, okay, as the factors. So what is a factor? A factor is a number that divides in. A factor divides into the number. So we're looking at this and we're going, hold on, we've only 3, and we cannot introduce any other prime number, so the only logical way it's possible is to add another 3. Okay, and if you did enough kind of assignments and experiments with number theory, you might know this already. Okay, so 3 by 3 by 3 is 27, and that's the answer. Okay, so just to kick this around a bit again, this 27 would be 3 cubed, or 3 times 3 times 3 if you expand it. So you would have 1, 3, 9, and 27 as factors. Okay, so a variation of this might be the number 8, because it would have 1, 2, 4, and 8 as factors. Okay, and so on. That's the answer there. And that's the end of question 1. As always, I will see you in the next one.